Hello everyone, this is Nilesh here once again. While discussing object-oriented programming, we came across static methods multiple times. And every time we keep telling that we can call the static methods without creating an object of the class. Even in the Hello World program, we seen the main method was static and it was called by the CLR without creating the object of the class. But today, it is time to discuss the static keyword in detail because the static keyword in C# is really versatile. It has got so many different uses. We can have the static fields, static methods, static constructors, static module initializer method. We can have something called a static class, the extension methods, and very importantly, operator overloading itself is done as static methods. Apart from this, we will also talk about the const and read-only keywords in C# today. So let us begin with the static keyword first. And let me get started with something very basic principle of the static. So the very first question, what exactly the static is? So static members are basically the members belonging to the whole class. They are not belonging to the individual object. Rather, there is a single copy of the static members, and that single copy is shared among all the objects of that class. Let me tell you that in VB.NET, there is shared keyword instead of static. So these members are always accessible using class name dot member name. Let me talk about some imaginary practical example. Let's say I want to write some code for a furniture showroom. And in that furniture showroom, we have different chairs having different weights or colors. But I want some common price for all of them. How I can guarantee a common price for all of them? Yes, that can be done using something called as a static. So let me create a new project. My name is a static demo. Now inside this, I want to create the class chair. And as I said, for each chair, I want different weight. I want different color. So I can continue making a different weight. And different color. But I want the common price for all the chairs. If you want common price for all the chairs, then you should write it as private static double price. If I create 3 objects of chair, then in each object we will have the separate weight, separate color. But for all 3 chair objects, we will have one common price. That's great. Let us quickly complete this chair class and create some objects, and then we can see this concept diagrammatically. So let me quickly write a constructor. And then I want to also write a parameterized constructor. I can use constructor chaining for initializing the default. Now I can write the properties. So I want to write the property for the weight and color. Similarly, let us write the property for the color. For time being, I can also override toString method. I guess that is fine. Now we can create multiple chair objects. Let's say this is my first chair object. I call it as chair 1. And in this particular chair, let's say the weight is 1 kg and maybe the color is red. I can create another chair C2, which is having, let's say, weight 2 kg and let's say the color is blue. Maybe I can have one more chair C3 is equal to new chair and let's say color is green. If you want to print each of the chair state individually, you can do it. Let me set the project as startup project and execute it. Great. Now, I was saying that I want a common price for all of them. By default, since I have not initialized anything, it is initialized to 0. But if you want, you can initialize it directly to the 100. This is nothing but static field initializer. Now I can display the price along with other members. Let's say I want to write price is equal to, either I can directly write price over here or I may write the class name dot price over here. Please note that do not try to make this dot price because the price is not belonging to the current object. The price has got a single copy and it will be now shared by all 3 objects of the class. So either you can use underscore price directly inside the class scope, or if you want, you can mention chair dot underscore price. Let me try to run this. Do you see that the common price is visible through all the chairs? Let me represent this diagrammatically. Consider the C1 reference. Let's say it is pointing to some object located at the location 1000. And inside that, we have kept 2 things. Number 1, we have kept the weight is equal to 1 and color is equal to red. This is the logical diagram representing how the chair object is created at location 1000. Similarly, you can draw another chair, let's say C2. For example, it is at the location 2000. And here we are considering the weight is equal to 3 kg and color is equal to blue. And similarly, you can also draw for the chair C3. But the question is, where is our price 100 is kept? Please note that the price 100 is neither part of object 1, object 2 or object 3. Rather, the static price is kept separately. It is having a single copy which is storing the value 100 and it is referred from both C1, C2 and even from the C3 object. Now that you have understood the basic idea of the static data member, we can go ahead and we can talk about the static method. You might have already seen that the static data member can be very well accessed inside non-static method of the class. However, what if I want to display only the chair price? Or what if I want to only modify the chair price? What I can do? So we can have one dedicated method, something called as a display price. And this display price method, I want to display the price. Let's say chair price is equal to something called as a underscore price. But how you are planning to call this method? Yes, you can call this method explicitly by saying c1 dot display price. Let me run this and you can check that the chair price is 100. But don't you think that exactly same outcome you will get it from c2 dot display price, c3 dot display price? In this particular case, though the price is common for all of them, we are displaying it as c1 dot display or c2 dot display, and it can be misleading. Ideally, if it is common for all chairs, it should be considered as chair dot display price. And for that, this particular method should be callable without creating the object of the class or without needing the object of the class, which can be done by declaring it as static. And now this particular code is more readable because here we are not displaying the price of a particular chair. Rather, we are displaying common price for all the chairs. On the similar way, you can also write the method for modifying the price of all the chairs. But instead of showing you writing a method for that, I'm showing you how to write a property for that. So let me quickly declare one static property, and that can be declared as public static double price. And inside this, just similar to our non-static properties, we can write the getter and setter both. And then we can use it to actually modify the price. Suppose we can directly modify the price as chair dot price is equal to 200. Now what will happen? This price is updated for all the chairs at once. So instead of 100, you will see the price is 200 for all the chairs. That is great. But have you thought of how you can initialize this particular static field initially? Please note that for the initial assignment, there are two options. One way is you can have static field initializer, or there is second way. The second way where you can write a constructor, but this constructor is for initializing the static members of the class, and that makes it as a static constructor. So the static constructor is to be written with the same name as of class name, but with the static keyword. Please note that there are no arguments to the static constructor because this particular constructor is always parameterless and cannot be overloaded. At the same time, you must see that there is no access specifier written for the static constructor because this particular constructor will be called by the CLR internally whenever the class is referred for the first time. So whenever the class is loaded, at that time, this particular static constructor will be executed. Now, inside this particular constructor, I might write, let's say price method is equal to 300. Please note that the first initialization will be the static field initializer, and then the static constructor will be called. So if any value assigned over here, that value will be eventually overwritten by this constructor. Now let me comment this line and you will see that the price 300 is shown for all the chairs. You see that the static constructor can be used for performing one-time job for any particular class. Now, suppose that what if I want to do something one time for the whole application, not only for a particular class? Then there is a concept called as a module initializer. We can specify one static method inside the class, and then this static method will be marked with the special attribute called as a module initializer attribute. This module initializer attribute tells CLI that this particular method must be executed before accessing any classes, any types in this particular assembly. So as soon as this particular assembly is loaded in the memory, it will internally invoke the module initializer. So let me check it over here. Let me write one simple class. Let's say the class name is startup initialization. You can give any name as per your choice. Inside this, I want to declare one static method. Please note that the method always return void and method doesn't take any argument. Again, method name can be anything. Whatever code we are writing over here will be executed only once. So I'm mentioning as module initializer, one time initialization over here. But for doing this particular method should be marked with one special attribute. And for that, you need to first import that particular namespace. So I will use using system dot runtime dot compiler services, and then I can use module initializer attribute. The attribute associate some metadata with that particular method, which tells CLR to call this particular method as soon as this particular assembly is loaded in the application. We will discuss about attributes in detail in later classes. Now let me just run this. And do you see that this module initializer is called at the beginning? If you write a console.writeLine statement in the static constructor, you will see that that is printed after this particular module initializer. I hope this clears the concept of module initializer. This particular concept is primarily used for setting up execution environment, or if you want to perform some sort of a startup checks, startup diagnostic before running any application, then that can be done into module initializer. This is another important use of the static keyword. Now I want to talk about something called as a static class. And this particular static class is nothing but collection of the helper methods or collection of utility methods. Please note that the static class object can never be created. So all the methods of the static class must be static, and they will be always called with the class name dot method name. Let me write some sort of a static class over there. For example, I want to write a static class, utility class. And this utility class, maybe I want to write simple methods like addition, subtraction. So you can mention it like public static integer add, and it will return you the result. Please note each and every method must be static. If your method is not static, then it will cause the error. If I'm making the subtract method as a non-static method, this will straight away give me the error that subtract cannot declare instance members in the static class. So it has to be declared as static compulsorily. Well, how do you invoke these methods? Since they are static method, they have to be invoked with the class name dot method name. And also very important thing, even though you wish, you cannot create the object of the static class. It is not designed for it. Let me show you practically. So in the main, if I try to create the object of the util, this will show me some error indicating that cannot create instance of the static class util. So you have only one way of calling the method, that is nothing but util dot add, and we can pass the value over there. Something similar we can call the subtract and pass the arguments to the subtract. Let me run this and you check this. I hope this is clear. The static class is always useful for grouping the related helper methods together. You can write multiple static classes in your application, maybe some related to your database handling helpers, some related to the file IO helpers, some related to some general utility functions, and so on and so forth. Now, apart from this, there is another special use case of these static classes. You've seen that we called these static methods using the class name dot method name. But sometimes you come across situation where you wish that certain ready-made class should have certain method. This particular class is either built-in .NET class, or this particular class is implemented by some of your teammate, but it is lacking a particular functionality that you were looking for. So can you go and modify the source code of it? Many times you do not have permission to modify the source code of others. And then the second thing that immediately comes to your mind is you can always write your class as derived class of the original class, and you can add extra functionality in that. But again, what if that particular class is a sealed class? If it is a sealed class, then you cannot do even the inheritance. Now, this is where you can add the extra methods in the class without modifying the source code or without inheritance, using something called as a extension method. This feature was added in C# 3.0. And in this particular method, you can call it on object name dot method name. Though technically it is not part of the class, but by looking at the function call, you always feel that this particular extension method is part of that particular class. It is kind of an illusion, but this is really useful and fruitful feature. Let me show you over here. Let us consider that I have something chair class, and let's say this particular chair class is written by some developer, and you are not allowed to modify this particular chair class, but you want that chair class should have one display method which is displaying the information about the chair. And now you are really worried how I can get that. This can be done without inheritance or without modifying the source code by using something called as an extension method concept. For this, we will write a separate class, and that class will be static class chair helpers. You can give any name as of your choice. Inside this, I want display method. So if you want display method, you can declare public static void display method. But this display method, you want it as an extension of the chair class. If you want this display method as extension of the chair class, then the chair class object must be passed as a first argument of that method. And very importantly, it should be marked with this keyword. It is kind of indication that this chair object is treated as current object. And inside this, we can display all the chair members one by one. Like I want to display the chair weight over here. I can also display the chair color over here. If you want to display the chair price, you can display the chair price over here. But please note that since the price is a static member, it is not accessed on the object. It is accessed on the class name. Now this particular display is an extension to the chair. What does it mean? So let me create another main. And inside this particular main, I'm creating the object of the chair. In this chair object, I'm passing, let's say 2 kg, and let's say color is black. Here C1 dot display. Please note that it is showing it as an extension and also one special symbol in the Visual Studio indicating that it is an extension method. You can check for the other methods like toString or getType. For this method, the symbol is little bit different. Let us check if it is working well. Let me run it and you can see the output. You can even debug this. And you will see that in this particular case, I can go to the function and inside the function, the C1 object over there is passed as a chair object as a this pointer. And then it will access all the public members or accessible members of the chair and that will give us the desired effect. This is not only for the user-defined classes, but this interesting feature is also available for the built-in classes. Like if you have kind of a string class, let's say I have string str is equal to, maybe I want to write something called as a Nilesh. In this particular case, what if I want to capitalize the string? So you find that there is a ready-made method available called as toUpper. What if you want to the lowercase? And again, you find that there is toLower available. But in case, if I ask you, I want to toggle case. I want every capital to make it small and every small to make it capital. How exactly you can do that? Now, there is no ready-made function like swap case or toggle case available in the string. Well, then this can be implemented using extension method. So instead of thinking of inheritance or like any other mechanism, I will continue to write my own class called as string helpers. And inside this, I want the additional method public static void. Let's say I call it as swap case method. And I want this as the extension to the string class. If I want it as an extension to the string class, the first member should be the string and it should be prefixed with this keyword. Now I want to change the case of each and every character. Well, how I can implement it now? I can use the for each loop. So for each character in the string, I can check whether this character is uppercase, then I will convert it to the lowercase. And that can be done by simply if character is uppercase, then character dot to lower, I will convert it to the lowercase. And in case if the character is lowercase, I want to convert it to the uppercase. But whatever result is there, I want to store it in a new string. I want to store it in a separate string. For time being, let me take some inefficient approach. Let's say string result, and I keep it empty, and each character, modified character, I will append it to the string. If the character is neither uppercase nor lowercase, I want to add it as it is. And then I can return this res. As I said that this particular approach is little inefficient. We can make it more efficient using something called as a string builder. And we will discuss about it in detail when we will talk about the string and string builder class. And this particular modified string I want to return from here. Now let us go to the main once again and check if this swap case method is available. So do you see that the swap case method is available? And in this particular swap case method, currently I'm not passing any extra argument, but it is returning me the string. So let me get new string and let me print this new string over here. Let me run this. Do you see that every capital letter becomes small case and small case letter become capital case? If you need some other utility methods and if you need some extra arguments, you can write the method accordingly. Let's say I'll write another test method which is taking some arguments to this. Let's say, for example, public static string, and let's say this is concatenation, where I want to concatenate certain variables into the string. Let's say I have some integer number and maybe I have some Boolean flag. I want to concatenate them inside this particular string. Can we do that? Yes, we can do it well. And that can be done by simply s plus equal to, let's say, number equal to num. So here I'm adding a number. And apart from that, I want to also add maybe some flag. So flag equal to the flag, which will be true or false. And then I'm returning the modified string. Now this particular stuff, I want to call it. Please note that this particular function is taking two extra arguments other than this extension. So let me give a try. I can write str dot concat. Do you see our concat method? And this concat method is taking two arguments, maybe one integer and maybe some flag. Let's say I'm passing true for sake of testing. And then I have, let's say, test string. Let me display this. Let me run this and you check that the original string plus concatenated integer plus the Boolean flag is available over here. As we will go ahead with the advanced .NET concepts, you will see that these extension methods are getting used behind the scene. Especially in a topic called as a LinQ, we will have the several extension methods available. It is common practice to create a separate class library for all extension methods, all helper methods that you want to attach to certain class or set of classes. And moment that class library is associated with your project, you will be able to use all those extension methods. Now that we discuss about the extension method static class, we are still left with concept called as a const keyword and the read only keyword. So let me consider one class, let's say circle class. And in this circle class, I want the circle dimension like radius to be immutable. Means once we declare the circle object, then I do not want to modify it later again. Is it possible? Answer is yes. And that can be done by making that particular variable as read-only. How? Let us give a try. Let's say private read-only double radius. Now, since this variable is marked as read-only, you can either initialize it directly in the field initializer, or you can modify it in the constructor. So you might have the constructor, let's say double radius is equal to something, and inside this you can initialize, let's say radius is equal to the given radius. So you can either initialize it into the field initializer, or you may initialize it into the constructor. However, you can never modify it into any other methods. Like for example, if you try to write some test method, and inside this test method, if you try to modify display radius is equal to any other value, it will straight away give you the error. You will see that there is an error called as read-only field cannot be assigned except in a constructor, or in an init-only setter, or maybe the field initializer, that is called as a variable initializer. So these are the only places where read-only can be modified. So you can use this method, let's say calculate area, and I want to return the area from here. I guess the logic is pretty simple. All I can do is return 3.14 into radius into radius. I hope that is straightforward. Now you can try to call this. And then the area can be printed just by saying calculate area. Let us try to run this and check the output. Yes, this is working as per our expectation. So you understood that the read-only variables can be modified directly in a field initializer, or you can initialize it in the constructor. You can also initialize it in the init accessor of the property. By the way, these read-only variables can be declared as static or non-static. If it is a static read-only variable, then it should be again initialized in the static field initializer, or you should be initializing it in the static constructor. Now you might ask, can I use 3.14 as a read-only variable? Yes, you can use it as a read-only variable. However, read-only is not a valid use case for this value, because the pi value is universal value and it is going to remain same for all the objects and even for all the classes. At that time, declaring it read-only doesn't make much sense. I would suggest that in this particular case, we should be using the const keyword. So let's say we can make it public constant double pi is equal to 3.14, and then I will use it over here directly. If you want to access this pi later on in your code, yes, you can even access that into the code. But please note that whenever you are accessing the pi value in the code, we are not accessing it with the object. Rather, we can access it with the class name, because though I have not written by default, all constant fields, they are static. And that is the reason they are always called using class name dot member name. Another important thing to note over here, the constant fields must be initialized using field initializer only. There is no other way to initialize the constant fields because these constants are internally replaced by the compiler in the IL code. So wherever the word pi is used in my source code, eventually it will be replaced by 3.14 into the MSIL code. And that is the reason compiler want to have this particular initialization done at the compile time with the fixed value. You can use const keyword only with the built-in types, while read only can be used with some user-defined type objects as well. So that option is available. Let us quickly take a look at the const and read only keyword. So const keyword must be initialized at the declaration. It is the compile time initialization so that compiler can replace it into the IL code. It is only for the built-in value types, not for the user-defined type. And by default, the constant variables, they are considered as a static when they are declared at the class level. Even if you try to write the static keyword explicitly for the const, it will give you the error. If you want, you can also declare the constant variables as local variables of the function. And the primary use case is for the universal constants like pi. The read only is bit different. The read only can be assigned at the declaration or it can be assigned in the constructor. It can also be initialized via init property. Basically, it is a runtime initialization. And this is usable only for the static or non-static field of the class. You cannot mark it as a local variable. And whatever variable is declared as read only, it is kind of remaining constant for that particular object. So we can have multiple circle objects with different radiuses. But once the radius is assigned, you cannot change it later by using property or using any other method or something like that. I hope this gives you clarity about the const and read only. Now, after discussing so many things regarding const, read only and static, let us go on to the last but a special topic called as operator overloading. You people already using operators plus, minus, multiplication, division, and so on and so forth. But by default, all these operators are usable with the built-in types. And what if I want these particular operators to be used with my user-defined class? You can do this by using something called as an operator overloading. Let me tell you, in this particular case, operator is nothing but just a function with the special name called as an operator along with the operator sign. And this operator must be declared as a public static function of the class. And then you can do the operation on that particular function. You may overload the unary operator or the binary operator as per your requirement. Let us consider a class called as a vector class. And let's say this vector has got only two values, x and y. Now, if I want to perform the addition of two vectors, I can think of writing a separate method for that, like add method. And in add method, I can pass v1, v2. But don't you think that vector.add v1, v2 is not that readable? Instead of that, I can consider using it something like this. And if I want to use it something like this, then what should be done? Then I need to write the method not as an add method, but I need to write the method as operator plus method. As I said, the method must be public static. Since it is a binary operator, I need to pass the vector1, vector2, both arguments explicitly. And then internally, you can have a logic which will return me the desired result. And this makes my code really, really readable. That is wonderful. Let us give a try on this first, and then we will talk about few more things about operator overloading. So I will continue the same example. Let's say class vector. And as I said that I want two members over here. One is X, another is Y. So we have, let's say, X and Y. You can continue writing a constructor and all other things. For time being, let me focus only on operator. So public static, and then I want to write the operator plus. In this operator plus, I want to calculate the result. And this result calculation will be the X is equal to addition of A dot X and B dot X. Similarly, I will have res dot y is equal to A dot y plus B dot y. And then I'm returning the result from here. This is simple vector class. Feel free to add the additional methods properties as per your requirement. Now, I want to call display vector class plus operator over here. For that, I will write another main. And in display main, I will declare two vectors. Let's say X is equal to 1, Y is equal to 2. And then we can have one more vector. Let's say V2 is equal to new vector where X is equal to 3 and let's say Y is equal to 4. Now I want to create the third vector as an addition of these two. Yes, that can be done by vector V3 is equal to V1 plus V2. Please note that whenever we are using the operator plus with the vector object, internally the call is resolved as vector dot operator plus, and then it is passing V1 and V2 as an argument. The resultant value is collected in V3. You can display the output. For displaying output, let me quickly override toString method. And in this method, let me mention X is equal to something and then Y is equal to something. Let me display the V3 over here. And I'm sure you are expecting 1 plus 3 is equal to 4 and 2 plus 4 is equal to 6. So the expected result is 4 and 6. Let's run this and observe the result. Let me quickly debug this by setting up the breakpoint in the plus. And then I can say F10. When I'm making V1 plus V2, internally it will jump to the plus operator function. And in this plus operator function, we will calculate the new result vector and we will return from there. And then the result is displayed over here. I hope that was interesting. Do you know that other than that, you can overload the minus, multiplication, division, and so many. But there are certain operators that has to be overloaded in pair, like equal to and not equal to operator, like less than and greater than operator. Let me give you the example of equal to operator. Equal to operator will compare the equality and it should return true or false. So it is static, Boolean, and let's say we have operator equal to. I guess the logic should be very, very simple. I can simply check a dot x is equal to b dot x and a dot y is equal to b dot y. So the implementation of equal to operator is very simple. But as I said that this particular operator must be implemented in pair with not equal to. You can check the error. The operator equal to requires matching not equal to be defined. And how you can define the not equal to operator? Well, you can write the inverted condition over here, or you can also show some smart implementation, like you simply return the not of a is equal to b. This can also be the implementation where this not equal to is internally calling the equal to operator. And we can cross check over here whether v1 and v2 are equal or not. How we can do that? Let's say v1 equal to v2. I will display v1 and v2 are same. Else v1 and v2 are different. By the way, in our case, it is different. So you can expect the similar output over here. So certain operator must be overloaded in pair. But there are some more limitations that you should note when you go for the operator overloading. So the first thing is at least one argument must be user-defined type. You cannot overload the operator with only built-in type. In other words, you cannot change the meaning of the existing operator. Second thing, you cannot even modify the precedence or associativity of the operator. Like if I'm writing 2 plus 3 into 4, the multiplication has got higher priority than the plus. By any combination of operator overloading, you cannot change this priority. You cannot change this precedence. Now, there are a few operators which define the core syntax of C#, and these operators are not allowed to be overloaded, which includes equal to operator, dot operator, type of operator, the new operator, then logical ending, logical ORing operator. These operators cannot be overloaded. And as I said that certain operator must be overloaded in pair. By any chance, if you are coming from the C++ background, in C++, the operator overloading is really rich, and at the same time, it is really confusing. There are so many different features implemented in C++ operator overloading, and it really makes it very difficult to grasp, especially for the beginners. I guess C# people realize the real problem with the operator overloading of C++, and then they kept it quite simple as far as .NET C# is concerned. But at the same time, they have leveraged the power of the operator overloading so that they can make their code more readable. So in this session, we talked about the static keyword, static fields, static methods, static properties. We talked about the static constructor. I also shown you the module initializer. We discussed about the static class, and we talked about the extension methods. We discussed about the const and read-only keyword. And most importantly, then we talked about the operator overloading. So in this big session, we try to cover so many different things related to the static keyword. And I'm sure as we will progress further, you will find all these things really helpful. Thank you very much for listening so patiently. See you. Bye-bye.